Good morning, good afternoon, good evening. Welcome back to chapter 15. We're talking about the macroevolution of Earth. We're talking about the major evolutionary events on the history of the planet. We finished up talking about the Precambrian. We talked about the Paleozoic. And now we're talking about the Mesozoic. The Mesozoic is when there are dinosaurs. The Mesozoic is broken up into the Triassic, the Jurassic, and the Cretaceous. The end of the Cretaceous is 65 million years ago. The end of the Cretaceous is the end of the dinosaurs. And what is it that finished off the dinosaurs? What finished off dinosaurs was a really big rock. It's a very large asteroid. One piece of evidence for the asteroid finishing off the dinosaurs, probably the strongest piece of evidence, is that iridium layer. Something that big would have to leave a big hole in the ground, a big crater. And so scientists were looking. It's like something like that should leave, a scar. We should be able to find this big crater. And they looked, and they had a hard time finding it. And then eventually somebody finally found it. And they said, I found it. It already has a name, though. And they're like, what do you mean it already has a name? It's called the Gulf of Mexico. The rock that hit the planet and killed off the dinosaurs hit the Gulf of Mexico. We'll look at that in just a minute. About 65 million years ago, remember we talked about plate tectonics, talked about plates moving around. About 65 million years ago, we had very similar architecture, very similar geography to what we see today. The difference is that India is an island. As recently as 10 million years ago, and we're talking about, 200 million. How far is 10 million? Not much. But in the terms of the lifespan of a human, a century, how long is 10 million? Holy God, that is like an inconceivable amount of time. What were people like 10 million years ago? There weren't any. Because you can't go back to find humans until the earliest things that you'll say, okay, that's not a human, but I can see how it's on the path to becoming a human. Maybe 3.5 million. Maybe 3.5 million years ago, you can find something that is human-like. And it's not really until you get to be about 2 million years ago that you find things that are decidedly human-looking. But even then, they're still not modern humans. And we'll talk about that in a bit. Modern humans don't show up for a very long time. So if we're talking about 10 million years ago, we had relatively present-day geography. We're saying that before there were humans, the geography of the planet looked pretty much the way it does today. That Cretaceous mass extinction about 65 million years ago, more than half of all marine species were wiped out. Many lineages, many terrestrial lineages were wiped out. And again, remember how fossilization, the process happens. It's really kind of hard to find fossils of land things because they have to fall in water to be fossilized. There are other things that can make them be fossilized, but it's really difficult. We have a good idea of what happened in water. We don't have a good idea of what happens on land. Again, we talked about the very large asteroid. Dust and debris blocked light and severely disturbed global climate for months, probably years. Very likely, at least 2 years, the sun was blocked out. This wiping out of the dinosaurs, and let's do talk about dinosaurs for just a minute. When you think of dinosaurs, you think of little bitty things, you think of big things. When we think of dinosaurs, we think of big things. Big things need lots of food. At the time the dinosaurs were wiped out, the pinnacle of mammalian evolution was a cat-sized possum thing. There probably weren't placental mammals at that time. The pinnacle of mammalian evolution at that time was marsupial pouches. Large animals need lots of food. If the sun's blocked out for 2 years, what does that mean for plant production? It means zero. It means no plant production. So what dinosaurs, assuming they survive the initial blast, what does that mean if there's no plant production? What does that mean for vegetarian? What does that mean for plant-eating dinosaurs? Well, it means they starved and died. They were the first ones that survived to die. Well, if the plant-eating dinosaurs are all dying because they're starving to death, what is that going to do to the meat-eating dinosaurs? Well, actually, they're going to have a really good time for quite a while because there's going to be lots of weak, dead, and dying vegetarian dinosaurs. They're going to do great. Woohoo! But then what happens when all the vegetarian dinosaurs are all dead and there's nothing for the meat-eating dinosaurs to eat? Well, then they all die. What about itty-bitty things? Little possum-sized cat things. How much food do they need? Not much. And could they get by on the scraps for a couple of years? Yeah, they probably actually could get by for a couple of years on scraps. So it is the reason why dinosaurs died was A, the initial blast, B, the sun was blocked out for at least 2 years. And dinosaurs were warm-blooded. They needed lots of food. And there was just no food for them to eat. So they died. And these things, these small things, did survive. This may not make a lot of sense to you, but I want you to know is that this is the Gulf of Mexico. That's Florida right there. That's Cuba. Here we are in middle Georgia. This is the big rock. It doesn't look very big in the picture, but again, this is the planet. How big is that relative to the planet? Not very big. How big is that relative to you? Freaking huge. So here we see, again, something we recognize, North America. Here we are in middle Georgia. This right here is where the asteroid struck. It's called the Titular Crater. And I exaggerated. The crater is not the entire Gulf of Mexico, but it is pretty darn big. It's about 60 miles across. Again, here's Florida, here's Cuba, here's the Gulf. Okay, this is the crater. This right here is referred to as the Yucatan Peninsula. You've heard of Cancun, Mexico. Cancun's over here. The Yucatan Peninsula, right off of Yucatan, is where the asteroid struck. This is a blow up of this area right here. All of these red dots that we see, these red dots are natural wells called cenotes. These natural wells were made of limestone. As water pools on the surface, it dissolves the limestone down, and again, it makes these natural wells. And when you think of a well, you think like something like this. Like, no, these things are like 50 feet across. They're huge. What do you notice? What do you see about that natural occurrence of these red dots, the natural occurrence of these wells, of these cenotes in the Yucatan Peninsula? Oh my God, you see an obvious ring. That obvious ring right here. That's the edge of the crater. When the asteroid struck, right here, it literally liquefied the Earth. It hit the world, it hit the ground so hard, it turned dirt into liquid. All of the cenotes in this area in here, if the dirt turned to liquid, what did they do? They filled in. That's why we see hardly no cenotes. These are new ones that have been dug since then. Because the Earth was liquefied, all the cenotes filled in. Come on, what else do you need? That ring is all you need to see of these naturally occurring cenotes. The Chicxulub crater, that's where the asteroid struck that killed the dinosaurs.